So in the previous session, we have discussed different types of angles. In addition to the angles, we have also discussed what is an latitude, what is an declination angle, and then what is the hour angle, a zenith angle, and azimuth angle. They play each and every angle plays a vital role in deciding. They are significant in their own way to study the solar radiations which are falling onto the Earth's surface. In that context, the one which is more important is the zenith angle, which makes, which decides the angle of solar radiations which are falling onto the Earth's surface with respect to the vertical plane, and if the same solar radiations which are falling onto the Earth's surface with respect to the horizontal line, we take it as an altitude angle. Okay. Now here we have got a small derivation or an expression which tells us the altitude angle. The solar altitude angle is an angle between the sun's rays and a horizontal plane. That is what I was just talking about. Now if you observe this sketch carefully, the alpha is the one which is making an angle of inclination or the solar radiations with respect to the horizontal surface, which is shown by a dotted line. Now if you can see this, my dear friends, the common sense says that sun is being indicated with a dark black spot. If I keep moving towards the vertical axis, towards the vertical plane, if I keep moving to the vertical plane, what happens? The phi becomes 0 or a minimum. That means phi, which is nothing but a zenith angle, and alpha is nothing but a latitude, altitude angle. So once the sun sets over there, then the minimum altitude angle will be there. Is it clear? So similarly, the z, which tells us an azimuth angle from the horizontal surface to the horizontal plane of identification with respect to the horizontal poles. That is what we call it as an azimuth angle. Sun's daily path, that is what it has been mentioned over here. Now as it just progresses and it just ends over here. Now we were talking about that hour angle also. It starts from the north, it comes to the east, then it goes to the south, once again it comes to the uh, west, and then it comes to the north. So as it just makes a completely 360 from 0 degrees to 360 degrees, that is can also be can viewed over here. Okay, now for an assumption, we have taken a centermost line as a center of the earth. This is nothing but a horizon. Horizon is a path or an imaginary line that we have considered around the earth's extra circumference. Is it clear? Now if you consider the solar altitude angle, which has been defined as the horizontal plane, okay, it is related to the solar zenith angle, which is given by, zenith angle is always given by 90 minus alpha. What is this alpha? Is nothing but altitude angle. So the zenith angle, it is given by phi, it is denoted by phi. It is related to the solar zenith angle, phi being a complementary angle between the sun's rays and the vertical plane. That is what. Then alpha is the zenith angle plus altitude angle is equal to pi by 2, which is nothing but 90 degrees. So obviously by the with a minimum common sense of a mathematics itself, we can make it out. This is nothing but this plus this will be equal to 90 degrees. That is pi by 2. If it is a pi, means completely from north to the south. Okay, the mathematical expression for the solar altitude angle, which has been given by sine of alpha is equal to cos of phi. It is the same thing. 90 minus alpha is nothing but phi. Okay, so what we get it here? So it is a common sense. If you take this as a sine of alpha, which is equals to sine of 90 minus phi, which is nothing but cos of phi. So sine of alpha is equal to cos of phi. It is the same thing. That is how you can define the zenith angle and also the altitude angle. They are interrelated. Okay. Now this zenith angle and the altitude angle will be is equal to sine of L, where L is indicated by local latitude. It's denoted by local latitude into the sine delta. Delta is nothing but the declination angle we have discussed in the previous session itself. So delta is nothing but the declination angle plus the product of cos of latitude angle into cos of declination angle into cos of hour angle, which is nothing but an hour angle. That will gives us the expression for the solar altitude angle. Is it clear? So this is the beauty of that. So altitude angle, sine of altitude angle or the cos of zenith angle will be is equal to sum of product of sine of latitude into sine of declination angle plus the cos of latitude angle into cos of declination angle into cos of hour angle will gives us an expression, mathematical expression in order to find out solar altitude angle. The sun is said to rise and set when the solar altitude angle is 0. That is what I was just, before this itself I was just telling you. The sun which rises is said to rise when the sunrise occurs. That means that altitude angle alpha is equal to 0. So as the sun rises, alpha altitude angle keeps varying it. Is that clear? So this is what. The sun is set to rise and set when the solar altitude angle is 0. So the hour angle at sunset HSS can be found from solving the equation for the altitude angle for H when alpha is equal to 0. Now for the same thing I can find it out. See here, sine of alpha is equal to, when alpha is equal to 0, when the sun is rising, you can calculate the hour angle. So sine of 0 is equal to 0 obviously. So the sine of latitude into sine of declination angle plus so and so. Cos of L, cos of delta and cos of HSS. You can use HSS or H which indicates the hour angle which reduces to. No, it is only because this uh, leads to cos of HSS. If you're dividing it, hold the equation from cos of L into cos of delta, because these two are common factors. What I'll do it is I will divide the entire equation by cos of latitude angle and into cos of the declination angle, then sine by cos will reduce to tan of L. So I'll take this onto the LHS, and this leads to cos of H hour angle is equal to minus tan of latitude angle into tan of declination angle, where HSS is taken as positive at the sunset. We have already discussed during the defining the hour angle. During the morning times we take it as negative, and even in the afternoon times we take it as a positive. That means from morning sunrise till the noon we take the hour angle as a negative one, and from noon till the sunset we consider the HSS, that is a hour angle, as a positive at sunset. Apparent motion of sun, this is what we call it as a AMS. Apparent motion of sun is nothing but the apparent which has been caused by the rotation of the earth about its axis. Apparent motion of the sun, obviously what we see, the sun in the east will be like this, and the sun keeps changing its path. As this is what we call it as a apparent motion. This is the apparent motion of sun. Actually it seems that the earth is not rotating, only the sun is changing its path. Actually what is happening, the earth is rotating. Likewise with respect to that also we see the change in the path. We feel that there is a change in the path of sun. Is it clear? So this is being caused by the rotation of the earth about its own axis, changes the angle at which the direct component of light will strike the earth. From a fixed location on the earth, the sun appears to move throughout the sky. That is what I was just talking. We feel that the sun is moving and the earth is not moving. Actually what is happening is earth is rotating it about its own axis. Because the earth is moving, we feel that the sun path is being changed. The rotation of the earth about its own axis makes the sun appears to move throughout the sky. The daily rising and setting of the sun and stars is due to the Earth's rotation about its own axis. It's known. Now the apparent motion of the sun from east to west across the sky during the day is familiar to all of us. But the Earth spins around its own axis just as a top spins around its spindle. It is just spinning it like a top which just actually rotates. Even if you take a ball, if you don't rotate it, it will be rotating about its own axis. So if you want to illustrate it with a better example, you can take it as a top. When you put a top over there, at a particular point, a needle end will be there for a top. It will be rotating its own axis. Even if it falls or bends here and there, but still it will be rotating with respect to that point of axis. That is what he meant to say over here. The spinning moment is called as a Earth's rotation. At the same time that the Earth spins on its axis, it also orbits or revolves around the Sun. This moment is called as a revolution. It is nothing but the revolution. The motion picture film is a strip of discrete, still pictures but produces the visual impression of continuous movement. In part, such effects of apparent motions called a visual phenomenon depend on the persistence of vision. Visual response outlasts a stimulus by a fraction of a second. The movement of a sun towards the earth or south in a year is called the apparent movement of the sun. Okay, the movement of sun towards the north or south in a year is called as the apparent movement of the sun. It is not the path that what we see it from the east to the west. Okay, the revolution of the earth around the sun and the tilted axis of the earth are the two factors responsible for the apparent movement of the sun or apparent motion of the sun. One complete revolution takes 365.25 days or 1 year. That 365, not exactly 365 days, 365.25 days for one complete revolution. That is the reason why we get a leap year, where we will get one extra day. In February we will get the 29th day. It is only because of this fraction 0.25. If you do remember, this is a plus or minus 0.25. That is what we have discussed in the previous angles. Exactly. The earth revolves around the sun because the gravity keeps it in a roughly circular orbit around the sun. To be frank, actually the earth revolving around the sun is not exactly circular. It is an elliptical in uh, shape. It is an elliptical in shape. It's a day length. How do we calculate the day length? It is a normal. I was just talking. If you go to any places like Rajasthan or desert places where sun rises at morning 4:30 or 5 o'clock itself, whereas here it rises at 6 o'clock. If you go to any cold countries where the sun rises at 9 o'clock in the morning and sets early at 4 o'clock, if you go to Rajasthan or any desert places where the sun sets, even you can see the light at night 8 o'clock. Whereas here we get the sunset at 6:30 or 7 o'clock in the worst case, isn't it? Now, based on the specific solar zenith angle, the sunrise and sunset does occurs. It is a normal the day length, what we term it as. The point from the sunrise till the sunset, that is what we call it as a total day length. No, no, it is a normal to measure the day length by specifying the solar zenith angle at sunrise and sunset. The solar zenith at sunrise or set is taken as 90 degrees 15 minutes. Okay, it is to be considered as 90 degrees and 15 minutes. The longer the length of the day time, the higher the amount of energy received. The shorter the length of the day, the shorter will be the exposure of the earth on the sun, causing lesser amount of solar energy. It is quite common sense. When more solar radiations are there, obviously we will be getting more energy. If it is a less, obviously less energy. Generally, the longer length of daytime, the longer its exposure, the higher amount of solar energy is being received. As a result of the slowing down of Earth's rotation, the length of the day has increased. The length of the day has been increased because of this. The rotation of the earth on its own axis, however, is affected by a number of other factors. For example, now here actually a day length, it keeps varying. If you consider this hour as a one point, where in a winter the sunrise will be at 7 o'clock and the sunset will be at 5:30 itself. Whereas the same one in the summer, what in the summer what happened? The sunrise will be at 5:45 or 6 o'clock itself, whereas the sunset will be at 7 o'clock. What is the reason behind of this? Irrespective of the, it is only because of the elliptical or the seasons which are being changing by the rotation of the earth, which is taking place about its own axis. Is it clear? Now exactly what we imagine, something like if you take a ball and make it a perpendicular hole, if you keep rotating like that, it is not exactly a perpendicular one, it is been rotating over here. That is first thing. Second thing is the earth which is rotating around the sun is not exactly a circular one, it is an elliptical one. It is an elliptical one. This is the reason why sometimes even we I was just talking about on the other day, I was also talking about wolf moon, or why the moon looks like orange or red. It is only because as long as the distance between the sun and the moon is far, it appears to be a different color. When it is near, it appears to be different color. When it is far, it appears to be orange or red mixed color. When it is nearby, it is a white. Is it clear? That means light need not to travel for a longer distance. The same thing happens why we see that the sun in a orange or yellow color in the morning and in the night. Why we cannot see it in the afternoon times? It is only because the solar radiations which are reaching onto the earth's surface on at a particular point of a place where we are observing will be entirely different one. So the time when the alpha, that is an altitude angle, is 0, from that to the maximum, that is from sunrise to the sunset, what is this duration, which is nothing but we call it as a total day length. And this uh, day length also depends upon the various factors. One of that factor is the rotation of earth on its own axis. However, it can also be affected on the number of other factors. Now, for example, if you take a force of the wind against the mountains, ranges changes the length of the day by plus or minus in milliseconds over a period of year. Now, the wind which is just blowing against, obviously, to be frank, what happens when you consider it as an earth surface? The earth has got the variations in the peaks, and it also has a mixture of greenery, dry land, and even the water. The most of the part of the earth is been also covered with the water. It is only because of that what happens, there will be a circulation, there will be a current formation, which we call it as a wind. Wind is nothing but air which comes with a higher velocity. This also makes a millisecond difference for a year. Maybe for a year it is a very small quantity, but it does matters plus or minus a milliseconds over the year. The day length is twice the sunset hour, since the solar noon is at the sunrise, middle of the sunrise and sunset hours. Thus, the length of the day in hours is being given by day length is equal to 2 divided by 15 cos inverse of minus tan L into tan of delta. L is nothing but latitude and the delta is nothing but the declination angle. So 2 divided by 15 will give rise to the day length of any particular point or place on the earth. This is how this day length has been calculated. Now let me consider radiation flux on a tilted surfaces. The power incident on a PV module depends upon PV photovoltaic modules, depends not only on the power contained in the sunlight but also on the angle between the module and the sun. When the absorbing surface and the sunlight are perpendicular to each other, the power density on the surface is equal to that of the sunlight. In other words, the pore density will always be at its maximum when the PV module is being perpendicular to the sun. Okay. However, the angle between the sun and the fixed surface is continually changing the power density on a fixed PV module, which is being less than that of the incident sunlight. The amount of solar radiation incidented on a tilted module surface is the component of the incident solar radiation which is being perpendicular to the module surface. The following, in the next slide, I just shall show you figure which shows how to calculate the solar radiations incidented on a tilted surface. So it is nothing but S module to a given either the solar radiation measured on a horizontal surface, that is S horizontal, or the solar radiation measured on a perpendicular to the sun. The equations relating now if you find out this, the equations relating to the module horizontal and incidented are given by alpha is the elevation angle and beta is the tilt angle of the module measured for the horizontal. The elevation angle has been previously given as alpha is equal to 90 minus phi is nothing but zenith angle plus delta declination angle, where phi is the latitude, okay, and delta is the declination angle. Delta declination angle is been given by 23.45 sine of 360 divided by 365 into 280 plus d. Okay, d is nothing but the day of the year. Note that the simple path 284 plus d is the equivalent to d minus 81, which was used before from the equation. A relationship between S module and S horizontal can be determined as S module is equal to S horizontal into sine of alpha plus beta divided by sine alpha. As you can see it here, alpha is the horizontal thing and the beta is the angle at which the surface is being tilted. Now this is nothing but an alpha plus beta. Now this yellow color one with the dotted line which indicates an alpha, and this is a beta. So the total inclination is being given by alpha plus beta. This is the S module, that is a module which is perpendicular to the tilted angle surface. Okay. Now this is a horizontal plane which is being considered. This horizontal plane which makes an angle of 90 degrees with the vertical line, and this is the solar arrays which falls onto this tilted area. The yellow lines indicates that the solar radiations which are falling onto this surface with an angle of alpha plus beta. So the incident angles which are making it as the S incident. This is a S horizontal and this is a S module.